Hello, students. Let's move on with the asymmetric key crypto system, where we are discussing about 5 algorithms, right? So the algorithms which we are discussing are this: PP-Hellman key exchange algorithm, RSA, Rabin, ECC, and Elgamal. See, the first two are done in the previous sessions. I hope everyone got it very well. Okay. Now, let us move to the Rabin crypto system. See, this Rabin crypto system is somewhat same as RSA crypto system only. But what may be the major difference between these two? A small variation is there. The variation wise RSA crypto system is totally dependent on exponential format. See, where we have utilized m to the power of e, right? We have utilized m to the power of e mod n, right? See, here we have utilized exponential format in the encryption procedure. Similarly, in the decryption procedure, we have utilized c to the power of d. Okay, so this exponential format is there in the RSA crypto system, whereas Rabin crypto system is totally dependent on the quadratic type. So here we will be encrypting with respect to the square, and decryption will be with respect to the square root. Okay, so square, I mean x to the power of square will be encryption side. Root x will be decryption procedure. Okay, I hope you got this difference between Rabin and RSA, right? So this is the only minute difference between the RSA and the Rabin crypto system. Okay, in this case of Rabin crypto system, there is a small, we can say it is not deterministic with the result. Okay, it is not deterministic with the result means we cannot understand what may be the exact result of the decryption procedure. I mean, we cannot decide what may be the exact plain text after having n number of results. See, one input will be giving 4 outputs. So these 4 outputs will be 4 equally probable plain text. See, can you see this point? So in the decryption procedure, we will be getting 4 plain text, 4 outputs. So out of 4 outputs, we should be thinking what may be my possibility of the plain text, and we have to decide the approximate one. So this is the only small disadvantage we have, right? So almost see, deterministic itself will be saying that point, right? I mean the quadratic, because in the quadratic you will be having root of x means, see, root of x means our output may be plus or minus y, yes or no? So in the plus wise, I'll go to some other procedure. Minus wise, I'll go to some other procedure. So this is the only difference we can identify in the Rabin crypto system. So extra complexity is needed for sure to identify what is my exact plain text. Okay. So let us move to the algorithm, right? So here in my algorithm, I am going to choose with 2 prime numbers, right? I am going to choose with 2 prime numbers, that is P and Q. See, everything is similar to RSA itself. Choose 2 prime numbers, right? See, whenever you want your attackers to get confused with a lot of plain text, then you can utilize this Rabin crypto system, right? And see here, choose n, I mean calculate n, which is the product of P and Q, right? See, public key will be directly our n value, private key will be P and Q. See, there is no E and D concept again. Okay, there is no E and D concept again. Directly with whatever the P and Q values we have, I'm finding n and placing that as a public key directly. And whatever the prime numbers which we have, I'm placing them as my private key directly. Okay. So I got my public key, that is n. I got my private key, that is p comma q. Now we are ready for the encryption and decryption procedure, right? So in the encryption procedure, we are going to utilize the formula as I have just intimated you about this. This is nothing but n square. See, m square mod n. Okay, in RSA, we will utilize m to the power of e. So that e may be anything, right? But here, this is quadratic. Directly, my value to the exponent will be 2 directly. That is m square mod n, right? So whatever the value we get as a ciphertext, we'll be sending to the recipient. Now at the recipient side, we are going to mention with m equal to root c mod n. Got this? Root c mod n. So this is the encryption step. This is the decryption step. Encryption step will be given the ciphertext, right? That ciphertext will be sending to the recipient, I mean the receiver. Now receiver will be taking that and applying square root of your ciphertext mod n, so that we will be generated with 4 combinations. So what are these 4 combinations? Again, see here. This is plus or minus C first. Yes. Sorry. Plus or minus C first. So I may have plus C and minus C. Now, after this plus or minus, I will calculate with private key P1s, private key Q1s. Minus C also, I will apply with primary key, primary number, that is, sorry, prime number P1s, prime number Q1s. Okay, so thus I will be generated with 4 combinations of data. I think you got how we got 4 equal choices of the decryption plain text. Okay, so when we have square root, so the square root output will be always plus or minus C, plus or minus whatever the data we know mathematically already, right? So that plus or minus will be a part of giving 2 outputs already. And these 2 outputs again with plus combination, my private key is P comma Q, right? As we just discussed. So plus will be applied with these 2 once again, and minus will be applied with these 2 once again. So thus we will be having 4 outputs. So to handle this, we are going to utilize Chinese remainder algorithm. See here, Chinese remainder algorithm. See, this Chinese remainder algorithm is nothing but you choose plus C with P and Q, plus C with minus C with P and Q. So like this, we are going to generate every output differently. See, while we are generating differently, we are going to give 2 values, 4 values. Okay, see, 4 values to the users. So these 4 values are A1, A2, B1, B2. Okay. Now, apply A1, B1 once with P and Q. Next, A1, A2 once with P and Q. Next, A1, A2, B1 with P and Q. A2, B2 with P and Q. Okay. So, there are 4 plain text, 4 M's. Okay, M1 to M4. See, choose one of the above M1 to M4 and appropriate plain text to be decided. Okay, so this is the thing which we have to know about Rabin Cryptosystem for sure, right? So let us see one example in the next slide so that you will be getting a small information how to create this and how to go carry on with this, right? See, let us select our P and Q as 23 and 7. So thus my public key will be 161 directly, right? So what is my public key? 161 directly, that is N. Now, what is my P and Q values? P and Q values are 23 and 7 directly. So this is my public key. This is my private key, PR. Now, I'm choosing plain text as 24. Okay, I'm choosing plain text as 24. So to find my ciphertext, my value is m square mod n, right? So m square mod n is nothing but 24 square mod n. So my value will be 93. So this is my ciphertext 93 I got. See here, ciphertext 93. So this 93 will be sent to the receiver end. Now this receiver will be taking this as plus 93 minus 93. Plus 93 minus 93. See, what is plus 93 with P? See, plus 93 with P means 23. Minus 93 with P means 23. Similarly, plus 93 with Q ones, 7. Okay? Minus 93 with Q1, 7. So like this, we will be generated with A1, A2, B1, B2, right? So A1 value is 1, A2 is 22, B1 is 4, B2 is 3. Okay? So after having these values, Chinese remainder theorem is given with one formula directly. So let us see this formula now. See, this formula is nothing but this one. See, just to find M with respect to your values. See, my M will be P and Q. So 161 is my N value directly. Now, M1 is generated by M by 23 means P value. Similarly, M2 is generated by M by Q value, 7. Okay. So, M1 is 161 by 23, that value is 7. Next, M2 is 161 by 27, Q value, that is 23 value. M1 inverse, similarly M2 inverse. So this value will be 10 and 4. So this is directly I am generating with all proper mathematical calculations. We have done this, right? See, after getting all these values, Chinese remainder theorem is given with one formula directly. See, this is if I have chosen my input as, let me go with the second choice. See, here I have chosen second choice. See, after having n number of choices, I have chosen A1, B2. A1 is 1, right? A2 is, sorry, B2 is B2. B2 is 3. Okay? A1, 1 and 3. See, this 1 and 3 I am applying here. 1 and 3 we are applying here. Okay? See how we are applying in this formula. A1 is 1, right? M1 just now we have calculated as 7, 7, M1, M dash. M1 inverse is 10, right? So 10. Next, B2. B2 is 3 from the previous one. So I took 3. Next, 23 is M2 and its inverse is 4. So I have substituted all the values, mod my n value so that I got 346 mod 61. So my value is 24. So this is exactly the plain text which I have chosen in my previous slide. See here, the plain text which I have chosen here is 24, right? So in this, out of all these combinations of 4 combination, second choice is giving the correct output. So similarly, we have to calculate all the remaining 3 also, A1, B1, and all the cases also we have to analyze and create. Okay. See, after creation and after we get 4 outputs, we have to analyze which may be the right output. So this is my right output. Okay. Bobs must be decide what may be my output in this situation. So maybe you got this. If you have any doubts regarding Rabin Cryptosystem, just feel free to contact, and always our textbooks is available, and even we also will be there always to help you out. Thank you for listening.